I'm Sriraman MG, co-founder of Find. We are a retail tech company based out of Mumbai and a subsidiary of Reliance Industries, India's largest listed company. Jio, also a part of Reliance, operates India's largest mobile network. At Jio, we are building an ecosystem of apps and services that span from telecom to entertainment to fintech and everything in between. Together, these apps and services serve over 500 million users. This year on Jio Cinema, we streamed the Indian Premier League, India's version of NFL for cricket, and clocked a record 32 million concurrent viewers for the final. Our various retail formats serve over 250 million shoppers every year. All these numbers are growing at unprecedented rates year over year, serving our customers with a personalized experience, improving our customer service, and optimizing operational efficiencies at this scale requires the use of AI and large language models. We wanted to leverage the power of AI to provide a unified experience to our customers across all our services. And for this, we are building a Copilot. A Copilot that will connect our various apps and services into one super app. For our customers, it will be a simplified one-stop shop for everything Jio. It can tell you when your Jio Mart order is out for delivery, give you a smart summary of the last episode you watched on Jio Cinema, or help you troubleshoot your Jio Fiber broadband connection. And to power this incredible experience, we chose Llama 2, Meta's open source large language model. And here's a preview of what we are building. Thank you. We started with the e-commerce use case first. We wanted to provide our customers with a seamless conversational experience to discover products, place and track orders. We wanted the Copilot to have enough user context to offer smart suggestions. Providing this experience involves working with lots of customer data. And we wanted a model that allows us to have control over our data while being robust enough to power these use cases. With Llama 2, we fine-tuned the 7B and 13B models for intent and entity detection in user messages. The fine-tuned model can detect intents like product discovery, order status, and general Q&A, and can map these to the respective Jio storefronts. We further fine-tuned the model for multi-turn chat responses by using around 20,000 chat records. For example, when a user types, "I recently joined a yoga class, what should I wear to the class?" The intent entity would be detected by the model first, and then a response would be sent by the multi-turn chat model to the user. Our Copilot is capable of answering all customer queries related to JioMart, JioFiber, and JioCinema. While the performance was encouraging, we also wanted it to come at a lower cost than other models. For this, we ran some experiments to host the model on CPUs and low-intensive GPU instances. We quantized the model and hosted it on CPU-intensive VMs and observed a throughput of 15 tokens per second. We are continuing to explore further in this direction to take full advantage of cost benefits. Now, of all the large language models out there, why did we choose Llama 2? 3 reasons stand out amongst many others. The safety and security of customer data is our #1 priority. Llama 2 gives us complete control over data and models, ensuring that our data is secure. We found building Jio Copilot on Llama 2 cost-efficient compared to other models. Rate limiting and quota issues are a blocker with other models. And all hurdles we come across during the development process are easily overcome with robust ecosystem support from the broader Llama developer community. So, choosing Llama 2 was a no-brainer for us. And today, we are excited to launch our closed beta. You can scan the QR code and join the waitlist to experience the next generation of Copilots. Thank you.
And now let's hear another example of taking Llama to the enterprise level from Shopify's Mikdad Jaffer.
There's a lot of work required to make things feel like magic. It should feel like something that is seemingly impossible happened without any effort. And when generative AI arrived, everyone rushed to create experiences that felt like magic. And I say magic because Arthur C. Clarke's third law is that any sufficiently advanced technology is indistinguishable from magic. My name is Mikdad Jaffer. I'm on the team at Shopify that is building AI solutions for our merchants. I want to take you through some of the things we've learned along the way and how we're making magic a part of our product. First, meet Sidekick. Sidekick is an all-aware AI assistant built right into Shopify. It understands all things Shopify and specific context about the merchant. It's able to step in and support merchants with whatever task they're working on. Sidekick can answer questions, fill out forms, edit themes, and even provide analytics. At Shopify, we believe all entrepreneurs are superheroes, and every hero deserves a sidekick. Let's talk through the journey of building this product and share what we've learned so that you can use some of the lessons to get started and build your own AI projects. To build Sidekick, we had to first establish how we wanted it to work, and then experiment with the available technology to see how we could get it to deliver on our vision. In many cases, generative AI and its capabilities and implications are still largely unknown. Merchants have questions like, does it know who I am? Does it know my buyers? How will it speak to them? How will it represent me? Will it always be right? What do I do if it hallucinates? These questions all stem from a fear of losing control. So when we were building Sidekick, we started with a simple rule for ourselves to follow. The merchant is the ultimate decider, and they should get to review the content before any changes are saved. To make sure that was true, we gave ourselves a constraint. The AI should only be outputting to the browser and should not have the opportunity to save changes directly to the server. To do that well and still allow Sidekick to take the actions it would need to, we created a domain-specific language, DSL, that was specific for Sidekick. It minimized tokens and created a set of commands that would be executed by our admin and not by the large language model. The model's job would simply be to determine the right set of commands for the task at hand. In order for the model to be effective, though, it needed to have the right context. And context in this case is what the merchant is doing, maybe things that they've filled out, where they are specifically, and more specific things about their store. So the context, the commands, and a good knowledge of how to complete that task is what Sidekick needs to make a good decision. When working with large language models, there are usually 3 ways to do so. You can prompt it to reference any existing knowledge. You can use something like retrieval augmented generation to get additional data into that prompt. Or you can fine-tune it so the model has more knowledge about what you want built in. As we were building Sidekick, we opted for a hybrid method that combined all of those approaches together. While there are many models available for fine-tuning, after our initial tests, we felt the best about the Llama v2 models. Llama v2 comes as models with parameters ranging from 7 billion all the way up to 70 billion, and we explored them all. But Sidekick has a lot of tasks to do, and that list will continue to grow. So we chose to go with the higher parameter models, because we felt it would give us the best chance at understanding the changing directions that would necessarily happen. Llama v2 gave us a cutting-edge model on which we could control the fine-tuning process. We could control the training curriculum, the hyperparameters, and observe and learn from the results. So it starts with the right data in the right format. Format-wise, we wanted to do an instruction-based format. The merchant's going to be asking a question or issuing a command, and the system needs to generate an output. Now, the space is really fast-moving, and new things come up almost every day. So we went with the basic JSON structure to house our instructions, and then convert them into whatever the instruction format was going to be for the week. However, the data that we had wasn't really perfectly suited for this format. So we're at our first issue. We have the data about how merchants use Shopify. We have subject matter experts that, when given a prompt, know how to provide what good looks like, but we don't know what the merchant is going to ask for or how they're going to ask for it. And we couldn't really launch something early that wasn't going to work. At the end of the day, our merchants run a business, and we don't want to get in the way of that. We had to release something that was going to help them and not frustrate them. So we turned to synthetic data. The goal was produce large, high-quality data that would improve the model's performance. This is backwards. I need to go back a slide. The lesson we learned here is that you don't need millions of data samples to do this. You can start really small with whatever you have. We started with 1,000 high-quality, hand-curated instruction and output pairs. We then fine-tuned two models: a forward model that takes an instruction and generates an output, and then a backward model that, given an output, generates an instruction. We then take all of the data samples we have, about 100,000 outputs, let's say, and we feed them into that backward model, and it determines what the instructions would have been. So now we have 100,000 instruction output pairs, which we feed into the forward model and tell the forward model to score those to see which ones are high quality. At the end of it, even if we only get 1% of that data to be good, we now have 1,000 new instructions, samples to work with. We retrain both models and rinse and repeat over and over again until we get as many samples as we need. The obvious question is, how do you go about creating 1,000 samples in the first place? So for that, we built a lightweight annotation system into our back office that the merchants use, and we put our subject matter experts on it. So why don't I just show you a demo of that system? So here, our subject matter experts log in and they have access to a dev UI. They can select an existing task or create one of the new ones. In this case, what we'll do is we'll create a new one, and we'll start with a simple message. This message is meant to mimic the instruction that the user gets. We start recording all of the actions that a merchant would need to do and finish in this task. In this case, we're creating a 20% discount. And once we're happy with it, we press stop recording, and it'll generate the Sidekick commands. We run it, test it, rate the confidence of it, and then save that answer. Then, alternatively, we have situations where Sidekick is having a conversation, and SMEs can go in there and edit the Sidekick commands. After that, same process. They'll make any edits to the code, run it, test it, and save it once they're happy with it. They're going to be rating it with a confidence level as well, just so that we understand which ones are good and which ones are not. Though, through this, we'll generate those initial samples to get us started, and can also use this to correct responses from Sidekick to improve our data. And while synthetic data is good as a starting place, it doesn't replace the value of real merchant-generated context. This gets us on the right path, but it still has the risk of not being a good enough answer for what the merchant will ask for. So to give Sidekick the best chance of being helpful, we made it output multiple options. The options give the merchant a chance to pick what they like, and in doing so, provide us with explicit feedback to create a better set of options next time. It also saves time for the merchant who doesn't have to ask for another option. So for us, this was a no-brainer. But now that we have the data, it's important to work through how to train these models to be effective at the task that we're giving it. For that, we ran through the good old scientific method and created a number of experiments to understand how parameters in curriculum would make a difference in the effectiveness. And with Llama v2 being open source, we could control all of these aspects ourselves. Now, if you've never fine-tuned a model before, this next part may feel complicated, and I'll do my best, but catch me later if you want to have any follow-up conversations. So Sidekick has multiple tasks that it needs to handle simultaneously, and we found that the parameter-efficient fine-tuning, or PEFT methods like LoRa's, were great for this. So we experimented through questions like, what's the optimal size of the LoRa bottleneck? Which is the rank? What's the rank that works best? What layers of the transformer should actually be adapted to be effective? Next, we wanted to figure out what the optimal curriculum would be for training. This is like trying to study for 5 tests at the same time. So we're trying to figure out what the best way to learn would be for that model. And we looked at, do we train each task separately and then merge them all at the same time? Do we train all the data, all the task data mixed together? Is it better for the model to learn one task before moving on to a certain other one? So should I learn how to navigate and then how to query data, or the other way around? And then does training a model on general knowledge first make learning from specific examples better later? We'll publish some of our findings as we confirm which of these approaches will be the most effective for others. It's important to remember that effectiveness is judged by the model actually solving the merchant problem. So before this gets into the hands of our merchants, we run each model through a suite of integration tests to make sure it's passing against the main things we want for production. With more human interaction comes more data that we can use for both training and evaluation. That's how we ensure Sidekick delivers something that feels like magic. It's an ongoing process and one that gets better with each iteration. At Shopify, we've made substantial strides with Sidekick. Our aim is to empower our merchants with an AI system that's not just sophisticated, but also trustworthy and easily integrates into their daily operations. Our experience has shown us that the rewards far outweigh the challenges, and each iteration improves speed, proficiency, and most importantly, merchant satisfaction. In navigating the complexities of model, data collection, fine-tuning, and UX design, we've not only elevated our own understanding, but have also set up a roadmap for developing these products in this landscape. So we just walked through the journey of building Sidekick and how you can get started on AI projects of your own using a cutting-edge model like Llama v2. While I'm excited for our merchants to enjoy the fruits of our labor, the beauty of this technology is that it's open source and accessible to everyone. I can't wait to see how you're all going to turn your ideas and this technology into everyday magic. Thanks.